This is another horizontal circle. It's actually identical to really like the last problem, although there's an in-between. They want to know the centripetal acceleration before we get the tension. But it's almost exactly like the last problem. So if you look at the problem, it says a 3 kilogram mass is attached to a string 1.2 meters long. So I know there's my mass and there's my radius. And it swings in a horizontal circle. The mass goes around its path once every 0.8 seconds. So that's how I'm going to get the V. I'm going to get the V from that. But it is string. It is string, so I know that my picture is going to have just one arrow like that. And if I write my descriptive equation, it's going to be T equals mv squared over r. Now, part A says what's the tangential speed, which is what I'd have to solve anyways. Even if I wanted to get the tension, I would have to solve for the tangential velocity to get it. So it's just breaking down the problem into things that I would have to solve anyways. So in part A, the tangential speed is v. And my starting point is that the mass goes around its path once every 0.8 seconds. So that means it's going to do one revolution every 0.8 seconds. That's my starting point. And then I just have to convert that into meters per second, just like we did in the last problem. So I extend the line, and I'm going to go from revolutions to meters. One revolution is, again, the circumference of the circle. So it's going to be 2 pi times 1.2 meters. And if you solve that, that's going to be your answer for part A. And I have 9.43. If you multiply that times that times that divided by that, I get 9.43 meters per second. So there's your part A. Now part B, what's the centripetal acceleration of the mass? Well, the centripetal acceleration is just, instead of mv squared over r, if I just want the centripetal acceleration, it's v squared over r. So I have all those numbers. It's just plug into the formula. So you're going to have v squared divided by r. So for v, we're going to put in 9.43 meters per second. And for r, we put in 1.2 meters. So just work that out, and that answer should come out to be 74.1. So here's your answer for part A. There's your answer for part B. Now, what? Well, there's no m yet because I'm not solving for the centripetal force. I'm only solving for the centripetal acceleration. Now what I can do is, if I want the tension, I can either use this formula, or I know F equals ma. Tension would equal ma. So whatever my answer is for part B, I can just multiply it by the mass, and I'll have the answer for the tension. Or I can plug all of those numbers in here. It doesn't matter which way you do it. So I'll just do it that way. So I'm going to, instead of using this formula, I'm going to just say, well, it equals ma. Tension would equal m times the centripetal acceleration, since I already solved it. So MAC. So I'm going to put in 3 kilograms. And I'm going to put in my answer from part B as the A. 74.1 meters per second squared. And notice that I'll get the answer in newtons, because tension is measured in newtons, and that's a kilogram meter per second squared. And 3 times 74.1, it looks like it's 222. Right?